Hi guys. So far we have seen about the thermal conductivity and electrical conductivity. So far we have seen about the metals. So in metals we have talked about free electrons and conduction electrons. As you know, last class we have derived the expression for thermal conductivity and electrical conductivity. So that is for metals. Now here we are going to introduce semiconductors. You people are well known about the semiconductors. Okay, so all the integrated chips, laptops, your amplifiers, oscillators, optoelectronic devices, sensors, scanners, everything will use semiconductors. Without semiconductor, the electronic world is not there. So semiconductors is very important. If since your IT students, since you people are IT students and ECE students are there, so both are having semiconductors. So as a ECE student, as a IT students, you should know about the semiconductor, because all the communication gadgets such as laptops, your mobile phones, sensors, scanners, everything consists of semiconductors. Semiconductors will act as a on-off switch. Semiconductors will act as an amplifier. Semiconductor will act as a signal detectors. So everything is of semiconductors. So wide variety of applications the semiconductors have. Okay, so now we are going to see about the introduction to semiconductors, types and properties of semiconductors. Okay. A semiconductor is a materials whose electrical conductivity value falling in between the insulator and conductor. Okay, so at low temperature, keep that in mind. At low temperature, the semiconductor will act as an insulator. At high temperature, the semiconductors will act as a conductor. Okay, so we can say the semiconductors in between the conductors and insulators. Okay, so you should not say it will conduct partially. Okay, it will conduct fully, but the correct definition for a semiconductor: at low temperature it will act as an insulator, at high temperature it will act as a conductor. Okay, so what we are going to do, we are going to change the conduction of semiconductors. How we can change this conduction of semiconductor, or how we can alter the conduction of semiconductors? By using the, or by increasing the temperature. So temperature plays a very important roles in the semiconductors. Okay, if you increase the temperature, there will be change in the conduction. So there will be, you have a lot of applications of semiconductors. So now, if you consider metal, we are talking about only one carrier. Okay, we will talk about only free electrons. But if you consider semiconductors, we will talk about two: electrons and holes. These are the charge carriers. Keep that in mind. For metals, only electrons are the charge carriers. For semiconductors, we have to talk about electrons and holes. These are the type of charge carriers. Okay, and electrical resistivity. The electrical resistivity of semiconductor is less than the insulator and greater than the conductor. See, it is in the order of 10 power minus 4 to 0.5 ohm meter. Okay, the electrical resistivity, we can alter the electrical resistivity, where in insulator we can't alter the electrical resistivity. Also in conductor we can't alter the resistivity, but it is the special for semiconductor. We can able to alter the electrical resistivity by increasing or decreasing the temperature. So this is very important point. Okay, now we are going to see about the properties of semiconductors. So semiconductors, keep that in mind. I will show one by one. Semiconductors are formed by covalent bonds. What is covalent bond? Covalent bond is a bond formed by the electrons. Okay, so whenever electrons in bonding, we will say that covalent bond. Okay, so semiconductors are formed only by the covalent bonds. At they have empty conduction band at 0 Kelvin. At 0 Kelvin, there is no conduction. So conduction band is empty, and they have almost filled valence band. So we will know very well know about what is meant by valence band and what is meant by conduction band. So for the semiconductor, conduction band at 0 Kelvin is empty, and it will have almost filled valence band, and the forbidden gap is very small. For metal, the forbidden gap is overlap with each other. For insulator, forbidden gap or energy gap is very high. But for semiconductor, the forbidden gap is very small, so that we can able to alter the forbidden gap by changing the temperature. Okay, next, it has negative temperature coefficient of resistance. This is very important point for all the semiconductors, that it possesses negative temperature coefficient of resistance. That is, when you increase the temperature, the resistance will decrease, the resistivity will decrease. When temperature increases, resistivity will decreases. This is a very important point for semiconductor. It has negative temperature coefficient of resistance. Temperature increases, resistance decreases. Okay, so and very important properties of semiconductor, we can alter the conductivity by adding impurities. This is very important. We can't do it in metals or insulator, but in semiconductor, when you add impurity, when you introduce a foreign atom to a semiconductor, it will alter the conductivity. There will be some changes in the conductivity. So these are the properties of the semiconductor. It is formed by covalent bond. It has empty covalent conduction bond. Valence band is almost filled. A small forbidden gap or energy gap. Negative temperature coefficient of resistance. That means decrease in the resistance while increase in the temperature. When we add impurities, we can able to alter the conductivity. Okay, so these are the properties. This is very important. So we'll go to the next slide. So you are seeing the material exist in the composition. So semiconductors, you can able to see semiconductors. There are two types of semiconductors: simple semiconductor and compound semiconductor. Of course, we have another type, but we will see the main type over here. This is regarding composition of material. Okay, that is about impurities. We have studied about intrinsic, extrinsics. That is about impurity, and this is about composition of material. Okay, so semiconductor, simple semiconductor is silicon and germanium. We have compound semiconductor. Compound semiconductor is one or more semiconductor added together is known as compound semiconductor. So we can see compound semiconductor. This is gallium arsenide, indium phosphide, gallium nitride. You can see two semiconductors over here, and this one is zinc sulfide, zinc selenide. Here also you are seeing two semiconductors. Here silicon carbide, silicon germanium. So here also you are seeing the two semiconductors. Okay, now so these are known as compound semiconductor. Simple semiconductor, only one element you have, silicon and germanium. Well, compound semiconductor, you have two or one or more semiconductors: gallium arsenide, indium phosphide, gallium nitride. So these are one or more semiconductors. So this is known as compound semiconductors. Okay, now see, you can see the periodic table. This is from second block of the periodic table, third, 4, 5, 6. Now you can see that germanium and silicon is from fourth block, and you can see zinc is third. So here we have given 2, and see here zinc sulfide. So zinc is from second block and sulfide is from fourth block. So we are saying this one is a 2,4 semiconductor. Just see this, compare this with the periodic table. Okay, so zinc is from second group, and silicon is from sulfur is from fourth. Zinc sulfide is from fourth group. So you are saying this one is a zinc sulfide. See here, zinc is from second, selenium is from sixth. Sorry, this is 2,6 semiconductor. Okay, so this is a combination of 2,6 semiconductor, 3,5 semiconductor, 4,4 semiconductor. So you can compare this table. So silicon and germanium is from the fourth block of the periodic table. So both are from fourth block. Okay, so this is about the composition of the material. This division is about the composition of the material. One is simple, compound. Simple is silicon and germanium. Compound is zinc sulfide, zinc selenide, gallium arsenide, etc. So now just see this silicon. How many atoms? 1, 2, 3, 4, 5. 5 atoms. Silicon the atomic number of silicon is 14. So see, the first shell composed of 2 electrons, second shell is composed of 8 electrons, third shell is composed of 4 electrons. You can see the electronic configuration of the silicon: 1s2, 2s2, 2p6, 3s2, 3p2. Now see the outer shell, how much electrons it possesses. The outer orbit possesses 4 electrons. See here, 1, 2, 3, 4. So this 4 valence electrons, the electrons which is present in the outer orbit or outer shell, is known as valence electrons. These 4 electrons are responsible for the conduction. Okay. Now see how the silicon atoms forming covalent bonding. Okay, so see, the covalent bonding is the sharing of 2 electrons. See here, sharing of 2 electrons. See here, sharing of 2 electrons. What electrons sharing? Covalent electrons will share. So it will form the, valence electrons will share. So it forms the bonding. So it will form the covalent bonding. So silicon valence at how many valence electrons? 1, 2, 3, 4. 4 valence electrons. So this silicon atoms have 4 valence electrons. This silicon have 4 valence. This 4 valence electrons. This one 4 valence electrons. This one 4 valence electrons. So what is the how it will form the covalent bonding? Sharing of 2 valence electrons will form the covalent bonding. So here, shared electrons. These are shared electrons. One electron from one atom. This electron is from this atom. So the sharing of valence electrons will form the covalent bonding. So this is the crystal structure of a silicon crystal lattice. This is the crystal structure of a crystal lattice. So this is how the electrons will, silicon will form the crystal structure, by sharing the valence electrons. If they share the valence electrons, they will form covalent bonding. Covalent bonding. And this electrons, if you give some temperature, if the temperature increases, this electrons will free from the covalent bonding and there will be a conduction. That I will explain you later. So now, as for this simple silicon is considered, silicon is a semiconductor is considered, you're seeing the crystal structure of silicon and how it is forming covalent bonds with the valence electrons. So if you increase the temperature, these covalent bonds, these electrons present in the covalent bonds will participate in the conduction. That I will tell you later. Okay. Just now write the electronic configuration of germanium, because silicon atomic number is 14 while germanium atomic number is 32. Germanium also have 4 valence electrons. So try to write the electronic configuration of germanium with the atomic number 32. This is the band gap of crystal structure, crystals at 0 Kelvin. See, for germanium, the band gap is 1.17 electron volt. For silicon, the band gap is 1.17 electron volt. For germanium, 0.74. For indium phosphide, 1.42. For gallium phosphide, 3.32. For gallium arsenide 1.52, cadmium sulfide 2.5, cadmium telluride 1.6, zinc oxide 3.4, zinc sulfide 3.9. So why semiconductor? The explanation of semiconductor technology is the use of semiconductor material to manufacture various kinds of modern day electrical devices such as computers, radios and phones. So we are using semiconductors in all the gadgets like laptops, mobile phones, sensors, amplifiers, signal processing, digital image processing. So everywhere you use semiconductor. So without semiconductor, there is no modern day communications. So semiconductor is vital because in all the optoelectronic devices, all the electronic gadgets will use semiconductors, on-off switches, oscillators, amplifier, etc. So these are some applications. We are using semiconductors in transistors, LEDs, solar cells, integrated chips, signal processing, and all sensors, etc.